everybody, and thank you, Ing, for the nice introduction. It's always nice to have a first thing, world's first, so we put that first. And thank you for SilTerra for the invitation. Really a great symposium and many, many relevant talks I heard today. And we heard the word spectrometer a lot today, so I'm talking about spectrometers too. And spectrometer is basically a lab instrument. It is well known since maybe 100 years. It's always expensive and it's big size. Some spectrometers are like this podium. So in my talk, we changed the name to a spectral sensor because the word sensor gives you the feeling that it's tiny, it's small, and it's semiconductor, right? So, and basically talking to you, so this is a product today. It's shown in the next room. And first generation and second generation, it is selling in different applications. I'm going to show you the technology, how does it look like, and some of those applications. Maybe talk about the sweat and effort as well. So first talk about Si-Ware. So Si-Ware is founded like 14 years ago. So we are a teenage company. And the headquarters is in Cairo, Egypt. We have R&D in Paris, France, and also we have sales and marketing in California. And we work with a lot of partners in Europe, in Asia, and in the US as well. And we are a fabless company. So we do our MEMS, our ASICs is all subcontracted to foundries like SilTerra. So this is a spectrometer. This is a lab spectrometer. This costs something like $100K. And this is the spectral sensor. This is the same actually. Of course, not exactly the same in price. It's much more cost effective and in size. Performance this is of course lower performance, but it's good enough for a lot of applications. So basically a spectrometer is an instrument for material analysis. So every material absorbs certain colors based on the molecular structure. So many people knows that. And basically the spectrometer detects those colors that are there, and from that you can determine which kind of material is there and how much of it is in the substance. And because it is small and integrated, we can make it affordable and we can use it in applications that were not possible before. And it's a winner of different prizes that we are very proud of, like the Prism Award. It's like the Oscar for photonics. You know the Oscar of movies? So this one is like, it's all engineers. No celebrities. So basically, if you look at an optical system, like Marcel just showed us some optical system, this could be like a 1 meter square, as you mentioned. This is a typical optical bench of a Michelson interferometer. We can look at it as the discrete form in optics. It's like the printed circuit board. And if we look at the integrated form, this is a MEMS chip, top view of the same system, scanning electron microscope, probably like a 10-year-old photo here. And of course, this is something like few millimeters by few millimeters. And basically, you see that all the mechanical, the motor is there, the optics, so when you look at this line, this is basically a vertical wall to the plane of the screen that is moving. And you see also the waveguides, you see the mirrors, the beam splitters, and everything. And it's kind of like the integrated circuit for an optical system. And it took us more than 8 years, actually, to develop this technology. All the effort to do the whole thing from scratch. No PDK. You have to do everything, mask biasing with the foundries, developing the process, etc. And at the end of the day, you have something like this. So this is called the NeoSpectra, the name of the product. We call it NeoSpectra Micro, because the first generation was called just NeoSpectra. It was bigger and more expensive and used for industrial applications. This one is much more cost effective. And it is all chips inside a single package. You have a MEMS chip, you have a photodetector, you have an ASIC, and you have some plastic optics, just a piece of plastic coated with metals for reflection. And of course, the product, the first generation has been selling since 2.5 years now. The second generation is going to ship in volume beginning next year. But we are already seeing some impact. So new models like mobile devices connected to smartphones, the IoT, the wearables, embedded sensors, all those buzzwords that we've been hearing this morning. And we see applications. For example, one of the very nice applications that was actually discovered by accident is skin cancer detection. It was a company in the US trying to do non-invasive glucose analysis. And they were not able to do it. It was too difficult, the accuracy was not that good. But by accident, they were able to detect a certain type of skin cancer very accurately, no biopsy, just by taking a scan of the area under doubt. Today it is used for agriculture, for soil analysis. So farmers usually need to analyze the soil to know the nutrients, how much fertilizer to put, what kind of crop to grow, etc. Also for the environment, for the air quality, so it can detect different gases like volatile organic compounds, like certain contaminations. For food testing and allergy, like we did in the other room, I will show you a demo where you can actually test your food live with an app on the phone. And you can see, for example, if you are intolerant to gluten, can detect gluten, if there is gluten in the food or not, how much caffeine, how much fat, protein, etc. And many other applications for pharmaceutical, for industry 4.0, as we heard this morning. We'll see a video summarizing those applications. Works. So this is Gen 1, this is Gen 2. So all the applications mentioned here are real-life applications that are either in production. This one is in production already. It's a Swedish company, a Dutch company, we're public about, called SilTerra, or in the design-in phase, about to go to market next year. This is actually a toilet. It's a company in the US doing urine analysis, continuous monitoring, as we heard this morning. This is a company in China doing oil and gas. Some other customer names who I cannot reveal, but those are the applications. So this is my last slide. It's basically a demo. So I have it in my pocket actually. So basically you have, it's not inside the phone, but it's, you know, the power banks that put in a sleeve around the phone. So we work with one company in the US that does those power banks, and we modified it so that at this side we add the spectrometer with a small lamp next to it. And you can detect, basically this is a demo I have in my pocket. It is here. So basically, this is an iPhone. And here is the spectral sensor. And we tested it here with Malaysian sandwiches. And it had gluten. So yeah, and you basically have an app where you can just, this is for coffee. You turn it on, and you can just simply see if it's it's detecting the level of caffeine there or not. This is basically the end of my presentations.